Okay, my people, let's look at we are still in oxygen series, so let's look at industrial preparation of oxygen. Okay, industrial preparation of oxygen gas. So how do we prepare oxygen gas industrially, and why do we even use industrial method to prepare substances, to prepare gases, for instance? So for industrial preparation, why do we do that? We do that because we want to get a larger quantity of any substance we are preparing. Okay, for oxygen we want to get you cannot, for instance, you cannot get the a large quantity of oxygen gas that is required to be used in the hospital just by using hydrogen peroxide or manganese 4 oxide, or by getting it from triosochlorate 5, has already been discussed in our last videos. So it's here we want to get in a larger quantity. So how we do that? We do that by getting it from the atmosphere direct. So how do we get oxygen gas from the atmosphere direct? I'm going to be quick so that the video will not be too long. So air contains oxygen gas, right? So how do we do that? You have to liquefy the air. By liquefaction of air, we get oxygen gas from it. So when we liquefy the air by mounting pressure on air, by compressing the air. So when you mount pressure on gas, okay, as case may be, in a lower temperature, with lower temperature, on cooling, on cooling about minus 200 degrees Celsius, the pressure that is being mounted will make the air to get liquefied, to be in form of a liquid. So before we do that, we have to remove some impurities like CO2 and other substances. So you have to remove it, and purify, by purifying the gas. So by removing CO2, the gas is being purified, and other substances, right? So it will be left with nitrogen gas and the oxygen gas. So but nitrogen gas is actually much more volatile than oxygen gas. So what is volatility? But this is just the readiness of gas to escape. Okay, so nitrogen gas can escape more faster than oxygen gas. So when we use fractional distillation method, once we heat the mixture of nitrogen gas and that of oxygen gas that is remaining, then nitrogen gas being much more volatile at around minus 196 degrees Celsius, nitrogen gas will escape, leaving oxygen gas behind. So oxygen gas, which is about 99.5 pure, will be collected through this process, and with this we'll be able to collect oxygen gas from the atmosphere in a higher amount.